So this is area part 2. It just says determine more complex areas between a function and the x-axis. This is not just a quick review from yesterday. I'm adding something here that's different. So this is at the top of page 10. So from yesterday, we have said the following, that if a function is both positive and continuous from x equals a to b, that's what it looks like, right? That's what it means. I mean, I don't know that it looks like that. It could be going down. It could be wobbling up and down. It doesn't really matter. Then the area between the x-axis and the function from x equals a to x equals b is given by this. Another way to say that is the area between x equals a, x equals b, y equals 0, and y equals f of x is that. But rather than writing that, and I've been holding my tongue because I just hate that a notation and the capital F notation, we can write this. Instead of writing that a with the vertical line from a to b, we write that elongated s, and that's called an integral, which means an antiderivative. And the nice thing about that, by the way, if you take a look at the shaded part of the screen, now I've got that. That's what's different in your notes. When you take a look at this notation, I'm leaving out the f of x, because I want you to think of that notation, what I've just written, as an operation. The argument of this operation is a function. So what does this operation mean? I mean, if I have this, and there's an argument in here, it just means take the square root of that argument. I really hope you know that a doesn't stand for area that I just wrote. Okay. If I have this as an operation, it means the argument is squared. When I have this, it means you anti-differentiate the argument using x as the variable that things are measured with respect to. And that's why when we write this is the same as saying that. And because we write that integral notation instead now, we don't have to worry about whether you use capital or lower cases. And you've encountered situations where they intentionally try to mess you up by using a capital for the function and something else for the antiderivative. So all this is saying, what's typed in the bluish kind of shaded area is, it's pronounced this way. The area is the integral from a to b of f of x dx. That's how we pronounce it. Which means it's the antiderivative of the function at b minus the antiderivative of the function at a. And what's very important, and for some reason I don't have it here, is it's going to make our lives really a lot easier when we do math, if we can use this notation. So I'm going to, not even gradually, I'm just going to dive right in and be using this notation from now on. So determine the area between 25 minus x squared and the x-axis. What is different from this compared to yesterday is I'm not saying from x equals something to x equals something. So there's an implication that there is an area that's obviously what we want to find. And we need to look at the graph. 25 minus x squared is a parabola that if you think of as going from this to this, I'll write it this way to help you out. You should understand that we are reflecting the basic parabola of y equals x squared vertically and shifting it up 25 units. So what this is going to look like is something like that. So what do I mean when I say the area between that function and the x-axis? Well, I think it's pretty obvious that what I am talking about is this area. And I'm not really that big on you having to put sketches, But I know in post-secondary, when you do written work, they want sketches of the functions. The reason why I'm not too big on it is we have graphing calculators in high school that we rely on all the time. You're not going to be able to have that luxury next year. Not most of you. So, what do we need to know? I guess what we need to know is what the lower and the upper boundaries are for that area in terms of x, which means we need to know the x-intercepts. But since the function is y equals 5 plus x, 5 minus x, I think it's pretty obvious that the x-intercepts are negative 5 and 5. So what I would have said yesterday, and you can decide not to write this down. What I would have said yesterday is the area will be this. What I'm going to say today is the area is the integral from negative 5 to 5 of 25 minus x squared dx. And what that means is, don't forget what I have told you about what this symbol and the dx are telling you to do to what's between them, which is called the argument. It's telling you to anti-differentiate it, and then that negative 5 to 5 is simply saying, do that BA thing. So this becomes the area is equal to 25x minus x cubed over 3, evaluated from negative 5 to 5. So I dropped the integral notation because I've already anti-differentiated it. You know, if I said to you, what is the square root of 16? And you said, oh, it's the square root of 4. No, you've already used the square root. You no longer write it. Same thing here. You've anti-differentiated that so you don't write the instruction. By the way, are we in agreement on the antiderivative? Or what I can now call the integral? Okay, so now we have to put in these numbers. I'm going to pause there because I saw a couple of, not puzzled looks, but is everybody okay so far with that? Okay. So this means I'm going to take 25 times 5 minus 5 cubed over 3 and subtract 25 times negative 5 minus negative 5 cubed over 3. And this set of brackets here is not needed, but I like for students to visually see that I have the same calculation being subtracted, it's just that it has a different input. You have calculators, I don't have any problem with you doing it on your calculator, but I'm going to do it kind of an old school way. I get 125 minus 125 thirds minus, I get negative 125 plus 125 thirds. Because the negative 5 cubed is negative 125 and I'm subtracting it. So the way I look at it is I have everybody 125 minus negative 125. And I like to do it this way because I have had students come back and say, you know what, I got a course I'm taking right now in calculus. I'm not even allowed a calculator. But they expect numerical answers sometimes. So 125 minus negative 125 is 250. I have negative 125 thirds minus 125 thirds, which is negative 250 thirds. If my math is right, I'm going to go 3, 750 minus 250. I'm getting 500 thirds. I'm seeing some people nod. So the area is 500 thirds square units. There's nothing wrong with verifying it on your calculator, but over the next couple days, I want to give you lots of class time to do math. So I don't want to verify all of these on the calculator, but we can verify this one. And then I want to talk about how I would have done the question instead, which is different. So we are trying to find the area. Where did my calculator go? We're trying to find the area between 25 minus x squared and the x-axis from the x-intercepts, which we know to be negative 5 and positive 5. This is just a check on your calculator. What's 500 over 3? 166.6 repeating? Probably. Thank you. So y is equal to 25 minus x squared. I'm going to set up my window settings to go from negative 6 to 6 and go from vertically negative 2 to 30. I'm basing that on what the y-intercept, we never talked about it, but the y-intercept is 25. So this is what it looks like. Looks pretty good. Nicer than what I drew. So I can go to my calculate menu and go integrate. That makes sense now that we're choosing that function. It's the integral of f of x dx from negative 5 to 5. Nice visual, 166.6. Okay, now I wouldn't have done the question that way. I mean, I still would have done the same question, but what I would have recognized, and you will see when, over time, you will understand when this is a benefit. Since this is a symmetrical function, that and this are equal in area. So if I instead say I'm going to find the area from 0 to 5 of, so the integral from 0 to 5 of 25 minus x squared dx, and I'm just going to multiply it by 2, I'll get there quicker, and here's why. The thing we're integrating is a polynomial, which means the antiderivative will be a polynomial with x in every term. And when we put 0 in for x, we don't even have to worry about that part of the calculation. It's really, because of this 0, it's going to be 2 times that. I mean, it's really 2 times this, but that's going to be nothing. I'm not going to go through and do that. I'm just pointing out that it's a strategy that would be a little bit quicker. All right, let's take a look at the next one. What is the area between x squared minus 2x minus 8 and the x-axis? So we need to look at what this looks like, which means we have to do a very brief Math 20-1 analysis of the structure of this function. The y-intercept is negative 8. Okay, that's not really that helpful. But if I factor this, it factors into x minus 4, x plus 2. And that tells me the x-intercepts. So we have an x-intercept of negative 2. And we have an x-intercept of positive 4. And we know this parabola opens up because it's positive x squared. The leading coefficient is positive. We can talk about polynomials. We can talk about rules from Math 20. This is a parabola that opens up. So I'm only putting in the axis of symmetry roughly so that I have a guide to graph it so it looks pretty decent, okay? So maybe the vertex is here, here. So this is what the parabola looks like. Now, what is the issue that we have to kind of work past here? It's that this is not a candidate for our rule. Because our rule says, and I only derived or proved the rule based on a positive function. And this function in between negative 2 and 4, boy, that's pretty... I want to just, not that it matters. I know it doesn't matter, but I just want to do a better job of this. He says as he draws the wobbliest parabola he's ever drawn. You get the idea, though? The area we are trying to find is this. But that is an area that is not below the function and above the x-axis. It's the other way around. Those of you that have taken Physics 30 or are in Physics 30 right now know that in applied sciences we often refer to this as a negative area. Like if you're finding impulse from a force time graph, that's a negative impulse. So what I am telling you is if you blindly did this, and I really do not want you to write this down. If you said, I'm going to find this, this is not going to be correct. It's not going to give you the area, because when I ask you in a calculus class, what's the area, I want to know an amount of area. This is going to be the negative of the area. Would you agree? Just from a physics standpoint. How can we fix this problem? The answer is to recognize, and I want to write this as f of x equals x squared minus 2x minus 8. The answer is to recognize, since the area is below the x-axis, I'm going to find the integral from negative 4 to 2 of negative f of x. Because when I multiply a function by negative 1, it flips it vertically above the x-axis. And it's going to be the same shape. It's just that then it will be above the x-axis. And, you know, you could do that, or you could just say that. One way or another, you need to recognize that when it's below the x-axis, you need to include a negative somewhere. Just visually to show that to you, and I'm just going to freeze this over here on the other monitor. This is what I'm talking about. That if the function is f of x, which I have highlighted down here, and you find the area using our rule, you're going to get a negative area, which is not an area. We can talk about it all we want in applied sciences, but this is a math class. So in order for me to make it into a positive area, I have two options. I can recognize that it's below, so it's negative, and that means I include this. Or I could flip the function over and use that as the new function. So I would do this. Negative 4 to 2 of negative x squared. Well, no, you know what I would do? I'm going to introduce you to this right now. You know where I have this stuff written in red, I said we could just put a negative in front to flip the whole thing over? I want you to get in the habit of understanding that this negative 1 here is just a factor of the integrand, and you can take it and put it outside. Just like, you know how we had that 3/2? We can move that outside, same kind of thing. So then I can put the actual function. I really don't care which way you go. I like this better. But again, I'm not putting the negative there because I do the whole question and go, whoops, I needed a negative, and I go back and put it. There's a reason. So what does this mean? It means I'm going to have negative 1 times x cubed over 3 minus x squared minus 8x evaluated from negative 4 to 2. Oh, it's negative 2 to 4, isn't it? Okay. How long have I been doing that? Somewhere along the way I switched it. It's negative 2 to 4. So now what we have to do is I'm being sincere. Math can be fun, but this is the least fun part of finding area. Now you got to put those numbers in. You got to grind away on your calculator. We're going to have negative 1 times I need to put in 4 cubed over 3 minus 4 squared minus 8 times 4. Subtract negative 2 cubed over 3 minus negative 2 squared minus 8 times negative 2. And don't forget that this entire thing needs to be multiplied by negative 1. And quite frankly, I don't care how you handle the numerical calculations of this. So I'm going to give everybody a minute or two to calculate what this is. I'm going to see if I can do it. So I get 36 square units. Of course, you'd probably run it through your calculator, but you do get 36. Okay. All right. Final example today, and then, as I said, for the remainder of today's class and for all day tomorrow, you're just practicing a whole bunch of these. Find the area between x squared minus 1 and the x-axis from negative 4 to 2. So this is a weird one because it's giving you an actual domain for the area, but I will tell you right now, this will be wrong. And I'm going to show you why it's wrong later, and I'm going to show you how we could figure out what it is on the calculator. This is not going to work. We need to look at what the graph looks like. X squared minus 1 is a graph that has an x-intercept at negative 1 and 1. That should be obvious because it factors into x plus 1, x minus 1. It has a y-intercept of negative 1. It's a parabola that has been started at the origin as x squared and shifted down 1. And it looks like that. Boy, I'm really parabolically challenged today. It looks like that-ish. But what you need to recognize is that this is negative 1, and this is positive 1, and we are asked to find the area from negative 4 to 2. Now, negative 4 is way over here someplace. If you want to extend your grid, I can't recall how big of a grid I gave you. I guess it depends on how you draw this as well. And 2 is over here. So what is it I am asking you to find when I say what is the area between the function and the x-axis from negative 4 to 2? Well, part of the function between negative 4 and 2 is the part that's here. And the area between the function and the x-axis is that area. Part of the function from negative 4 to 2 is from 1 to 2. And that means we have to find this area.
It's negative 4 to 1.
On yours it says to 1? Oh, even better. That's going to make it a little bit simpler. Thank you, Eli. So we don't have to go there. Okay? But it does go from negative 4 to 1. That means we need to find the area over here. And I now realize why I said only to 1, because as you'll see in a second, this will be enough. If we go another one, it's going to be even more. So let's call these areas 1 and 2. How do I find area 1? Well, area 1 will be the integral from negative 4 to negative 1 of x squared minus 1 dx. That will be that area. Because the function is above the x-axis there, I have that rule from yesterday. Area 2, so I need to add area 2. Area 2 is not this. Area 2 is this. Because area 2 is an area that's below the x-axis, I need to multiply that integral by negative 1. I mean, really what I'm doing is I'm flipping the function over, and this will become clearer in a second when I look at my calculator. So you need to be very careful here. Some of you might decide to take that negative and put it in here and write 1 minus x squared, which quite frankly I think would be a wise move. How many of you would like to do that? Math is not democratic, but I'm just wondering how many of you would prefer to do that? I would, because then I have fewer negatives to deal with. So I saw enough people nodding. Oh, by the way, come on. By the way, and I don't know where I've seen this, but I've seen it in textbooks. I can't tell you exactly which textbooks. I have seen people get rid of this negative and take the negative 1 and the positive 1 in the integral and switch them. Now, that will work. It will work, but it's wrong, in my opinion. Okay? So, what are we going to have? We're going to have x cubed over 3 minus x evaluated from negative 4 to 1. And I didn't put that vertical line in, and sometimes I don't. From negative 4 to negative 1. And we're going to have x minus x cubed over 3 evaluated from negative 1 to 1. And by the way, you could have, for this middle area here, you could have just gone from 0 to 1 and doubled that. Okay, so we're really practicing our number skills here. Negative 1 cubed over 3 minus negative 1 minus negative 4 cubed over 3 minus negative 4. And then we have to add, and I need another set of brackets here too. I need a set of brackets around that. And then we have to add 1 minus 1 cubed over 3 minus negative 1 minus negative 1 cubed over 3. Man, talk about your test of working with negatives, right? This is maybe the most challenging part of the problem. I just want to step back and look at that. It's negative 4 to negative 1 for the first one, so it's negative 1 cubed over 3 minus negative 1 minus negative 4 cubed over 3 minus negative 4. I'm adding the next area, which is 1 minus 1 cubed over 3 minus, in brackets, negative 1 minus negative 1 cubed over 3. There you go. I'm not as confident this time around with just using my brain, but I'm going to give it a crack. So the area is 58/3. I just want to double check something here, just to satisfy my curiosity. Yeah, I got my negative screwed up here. I think this should be negative as well. Anyway, 58/3. If you make a mistake, it's probably going to be in that final stage where you're doing those calculations. Now, let me demonstrate something to you. I told you at the beginning that you cannot do this, right? Cannot do this. Let's look at what happens if you do. And I think there's something valuable to be learned about this that will be useful later. I'm going to put in x squared minus 1. I'm just going to go zoom standard. And I'm going to go to my calculate menu and find the integral from negative 4 to 1. I'm going to change that a little bit. Okay, I'm going to go to my integral function here in the calculate menu and go from negative 4 to 1. And what it calculates is this. And that's not 58 over 3. What is 58 over 3? 26.3, no.
19.3.
19.3 repeating. So why is this not right? Because this integral from -4 to 1 does have a meaning. But what it is all of the positive area minus the area that's below. It treats the area that's below as negative. So if I wanted to check this on my calculator, I would have to fold that bottom part up, wouldn't I? Or is a perfect way to do that. I graph the absolute value of the function. And now, Math 20, everything is above the x-axis. And if I go to my calculate menu at this point and go -4 to 1, I get the answer. So I'm effectively showing you a way to kind of cheat. Now, it's not perfect, right? It's because it should be 19 point exactly 3 repeating, and it's not. But we've run into that problem with these calculators before. You know, I'm not telling you that this is maybe a good thing to do or the right thing to do, but I'll tell it to you anyway. And when there comes a time where you can't do this, then you're on your own. You'll be in post-secondary. You'll have enough struggles to deal with anyway. This is your work. Nobody cares how you get the answer from here. So go to your calculator, do what we did, get 19.3 repeating, and figure out what it is in a fraction. You don't have to show every little step, right? I guess I'm telling you how to cheat the system a little bit. So here's the bottom line. Some students will still wish to think of capital F of x as opposed to integrals, and that's fine. When we look at what we're going to be doing on Friday, it's going to cause grief if you do that. So the quicker you can make the transition from here to here, I think is the better for you. On page 454, question 1 are all questions that I am pretty sure all of the functions are entirely above the x-axis and continuous over the interval given. But as soon as you get to number 2 or 5 or 6, you need to then start relying on looking at a graph. Clearly, I mean, we've got 80 minutes tomorrow plus a little bit less than a half hour today. You have lots of time to practice these, but some of them could take 15 minutes. And some of that time is going to be me going over stuff with you. So that being said, there's no way you're going to do every single question. All right, so get to work on these, get some practice and get settled in, and then I'll help you out. Yeah. Yep.